Okay, in this video, we are going to look at the approximation using tangent line. Approximation in BC calculus is done 3 different ways. This is very important in BC calculus. The one is using tangent line. Tangent line is a line, that's why we call linear approximation. Then in second semester, third quarter around, we will be learning approximation using Euler's method. And this is the last part, is a huge portion of the BC calculus exam, is a approximation using Taylor series and Maclaurin series. So you can say that the approximation in calculus is 3 different ways. The first is AB calculus, and these 2 are for BC calculus, but we have to cover all 3 of them. So just like you approximate, when you are approximating, always the question is how good is your approximation? Which approximation gives you better answer? First one, why we are not happy with the line, why we have to use Euler's method, why we have to go for Taylor's or Maclaurin series. So all that comes up to how good is your approximation? Can we have a better approximation method? We need to know concavity of the graph. So for example, let's start with the tangent line. This is my equation of tangent line, and I find the equation of tangent line at C. Now, if I'm using this equation to approximate the values, is my approximation is going to be underestimation or overestimation? And for that, we need to know concavity. So let's take a look at this lesson into more details. So here we have understand the concept of tangent line approximation, compare the values. We will talk about that. Don't worry about the error part. Let's talk about this warm-up. Find the equation of tangent line at x equal to 0. So we know the equation of tangent line is y minus y1 mx minus x1. We have done this before, but today we are going to use this equation of tangent line and find the answer of approximation. So 1 plus x to the negative half. If I'm finding y prime of 0, if I'm trying to find the slope at 0, the slope will be 1/2. So my equation of tangent line will be y minus, if I substitute 0, y minus y1, so that will be 1, slope is 1/2, and x minus 0. So I can write this equation as y is equal to, easy way to write is 1/2 x plus 1. This is my equation of tangent line. I'm sorry for my handwriting as usual. Some of you already know my pen is not really clear writing. So that will be my equation of tangent line, 1/2 x plus 1. Now consider the f is differentiable at C. We already took care of this. F prime of C, that's a slope at C, which is called equation of tangent line approximation. Now, how do we work on finding approximation? So we got the equation of tangent line in a point slope form. Solve for y, which we already did. That was my equation, y is equal to 1/2 x plus 1. Give a name, new name. We call this is my linearization. So that's why we use the letter L. L of x is same as y is equal to y1 plus m x minus x1. That's the same as my equation of tangent line, but since we are going to use it, and there will be 2 y's, to differentiate that, we give the name L of x. Okay, so just a few minutes ago, I told you that how do we know it's overestimation or underestimation? The best way to visualize this is to sketch the picture. If it is concave down, and my approximation is over approximation. If it is concave up, my approximation will be under approximation. This is very important topic to figure out, and if you have to justify, you just have to write that concave up, underestimation, concave down, overestimation. So let's take a look at exactly the example we have in the warm-up. From the warm-up, we already got this is the same equation. use this to approximate square root of 1.02. So equation from the warm-up, we have y is equal to 1/2 x plus 1. Now 1.02, and if I have 1 plus x, so x will come out 0.02. So if I'm using my equation of tangent line here, I will have approximation f of 1.02. Approximation is going to be 1/2 0.02 plus 1, which is 1.01. I should not write here f of f1 because that's f of x. This is actually 1.02. Approximation using my equation of tangent line is 1.01. You could check in the calculator. If you type in the calculator 1.02, my answer will be 1.01 using calculator. So how do we know my answer is overestimation or underestimation? For that part, we can check the graph of square root of x plus 1. This is my square root of x plus 1. I'm sketching the tangent line at 0. And if I'm using this green color line to approximate any values on the square root, you will be able to see that it is going to be overestimation. We are going to look at another example here. Find the equation of the tangent line to the graph of this. So first of all, let's find the derivative. F prime of x is equal to 2x. My equation of tangent line is y minus 4, slope x minus 2. What will be the slope? F prime of 2 is 2 times 2. Slope is 4 also. Okay, so this is equation of tangent line. Okay, now use this equation of tangent line to approximate 2.1. Not using the actual function, but using equation of tangent line. So that will be t of 2.1 using approximation squiggly line. If you rewrite this equation, which will be 4 plus 4 times x minus 2. So that will be 4 plus 4, x is 2.1 minus 2. 4 plus 4 times 0.1, and my approximation is 4.4. Okay, is the approximation greater than or less than f of 2.1? So to find that, you don't have to sketch the graph. You have to prove the concavity. Now we already know, let's not look at this equation. We already know that x square is concave up. If I'm trying to sketch the tangent line at 2, this is clearly under approximation. But what if you don't have a graph? For that part, you have to find the second derivative. And that's what we learned. The second derivative is from here. Second derivative is 2, which is always greater than 0. So you can say f of x is cc up. Therefore, approximation is under approximation. So we look at very basic, simplest question. Draw the equation of tangent line, use the equation of tangent line to approximate the further value, call it like extrapolation or interpolation, and how my approximation is going to be. Is it going to be under or over? For that part, we need a second derivative. Now, this piece is different. Mathematician has used a different way to explain. So I'm using this notes here, which is already given to you. In in the packet. So you know that the calculus is being, so many mathematician has contributed in calculus. So what's the difference between dy dx and delta y over delta x? Leibniz did most of his calculus using dy dx as a separate entities. So in this case, all you have to know that dy, until now, we always looked at dy dx as the same thing as a slope. But you can separate dy and dx as a separate, and then you can say that the dy is a change in y, dx is a change in x, and you can consider as independent variables. So one thing only I have to explain here is, we know that the dy dx is f prime of x. All we have to do it is, sometimes we separate it. If we multiply both sides by dx, we can say dy is f prime of x times dx. We are going to use this in the next unit where we have to do antiderivative to come back. So for now, just remember that dy dx is the same as f prime of x, and if we have to separate that, you can multiply both sides by dx, and this is also same as change in y is the slope times change in x. Now, we are not going to do this example here. I just want to explain that how some textbooks are using all those derivatives. They call it differential form. This is just for your understanding that not all the time we write dy dx. I remember when I was in college, we used to always write dx, differential, and dy. We never wrote dy dx. So d is the form it's telling you derivative. D is the one which tells you derivative. D is for derivative. So this is another way to write all those derivatives. Like here, you can say x squared, we write it dy dx is equal to 2x, we solve it. So this is called derivative, this is called differential. Solve for dy is 2x times dx, so these are called derivatives, these are called differentials. These both are same, it's just written different way. Okay, so let's take a look at some questions. The one you have seen, you are going to see in the AP exam. So we are going to do a couple of multiple choice and couple of free response questions. Yes, this topic is important. Yes, you have to know how to do this. And yes, it is very simple one. So let's take a look at what is linearization means. Make connection straight away. Tangent line approximation. Tangent line approximation. Okay, so first of all, let's find the equation of tangent line. At 1, function is e to the x, so y minus y1, mx minus x1. Y minus y1, if I substitute, I get e to the 1, x minus 1, m. Slope of e to the x, derivative of e to the x is also e to the x. And if I substitute at 1, that's also e. So which would be the answer? Let's take a look at this. That's my equation of tangent line. Equation of tangent line. So which would be the answer? So if I simplify here, y is equal to e goes on the other side plus e to the 1 times x minus e. This to get cancelled. The answer is a B. Okay, number 2, f of x, equation of tangent line is used. Okay, so based on this, you can see this is a calculator question. F of x is x squared minus 2x plus 3. Tangent line to the graph of f of x equal to 2 is used to approximate f of x. Which of the following is the greatest value of x for which the error is less than 0.5. So here f prime of x is 2x minus 2. So f prime of 2, we are using at 2. So my line is 2. Equation at x equal to 2 would be, they did not give you y value. See, y minus y1. M is a 2. x minus 2. You have to find y1. So substitute 2 here, which is 4 minus 4 plus 3. So that number is a 3. Y minus 3, 2, x minus 2. This is my equation of tangent line. Now this says, what values of x for which the error resulting is going to be the smallest value? So for this part, you have to put in one at a time in a calculator. You can use in the calculator. This is what I did in the calculator. I put this in a y1 is equal to my original function, x squared minus 2x plus 3. And I did y2 is equal to this line, 3 plus 2x minus 2. You put it in a calculator, you go in the table and you can see which equation gives you the smallest error. Error is always the difference, subtract. So what I did is I did y3 is equal to y1 minus y2. And I looked in the table and checked which numbers give me the smallest error. And my answer for this is, the answer is 2.7. The smallest value. So this is a quite tricky question actually. You have to have a calculator skills to use. How do we just put this y1, your equation of tangent line, y2, error is the difference between two, error is the difference between two. You don't have to worry about positive, negative, error is absolute value, and which x value gives you the smallest error. Okay, so let's take a look at number 3. Number 3 is f of 3 is equal to 2, f prime of 3 is 5. Oh, this is a no-nonsense, straightforward question. Let me erase all this. No-nonsense, straightforward question is y minus 2, slope is 5, x minus 3. Use this. Now find an approximation of 0 of f. That's the only part. Zeros of f means, zeros means x-intercept. X-intercept means y is equal to 0. So substitute y equal to 0. You will find the x value. And that comes out 2.6. Those are the answers. Last one is not that tricky as well. Y is equal to tangent x, x equal to pi, dx equal to 0.5. What is dy? So this is what I was talking about. Dy dx is derivative of tangent is secant square x. So I can say dy is equal to secant square x times dx. X is a pi, so secant square pi. Dx is 0.5. Secant square pi times 0.5. What is secant pi? Cosine pi. Cosine pi is -1. You are squaring, so that's a +1. +1 times 0.5. Answer is this. Okay, so let's take a look at free response question as well. So here on your packet, page number 46 is a free response question. Page number 46 is a free response question. You can see this is 2010. Free response question usually have A, B, C, D. This is only A and B. Maybe the C was the Euler's method and the D was another one. But this is the AB calculus, so Euler's method is not in that. Let's take a look at this first one. Write an equation for tangent line for the graph of f at x minus 1. So first, y is equal to x value they gave you. They did not give you the y value. So x equal to 1. They gave you f of 1 is 2. So that means y is equal to 2. So what's the slope? Oops, oh my gosh. Slope. What's the slope going to be? You can say y minus 2 is equal to x minus 1. How do you find a slope? So this is the slope equation M. So M is xy cube. X is 1, y is 2, so that is 8. So y minus 2 is equal to 8x minus 1. That's my answer for A, equation of tangent line. You don't have to, you get full credit if you write like this, but if we are going to use this approximation again, it would be easier if I write my answer like this. Okay, so let's talk about B. Use the tangent line equation to approximate f of 1.1. Okay, so that means I have to approximate f of 1.1, approximate, which means x equal to 1.1. So 2 plus 8 times 1.1 minus 1. You get a full credit if you stop here. Stop. You don't have to simplify. You don't have to simplify. Don't have to simplify. But we can't resist. 1.1 minus, that's 1.8. So the answer will come out 2.8. Okay, so we did this. Now let's read further. Given that f of x is greater than 0, is my approximation greater than, less than? That's very interesting question. And here is the one you are using second derivative. You were wondering where do I use second derivative? So let's work further whether it's overestimation or underestimation. So I'm just copying my second derivative here. D square y over dx square is equal to y cube 1 plus 3x square y square. X is 1, y is 2. Substitute. 2 to the third, 1 plus 3 times 1 times 2 square. Again, do not simplify. Check, is this going to be a greater than 0 or less than 0? Obviously, all these numbers are positive, so I can say greater than 0. Greater than 0, which means CC up. The question is, how do you explain? This is a part of my work, whether overestimation, underestimation, you must write the reasoning. So I will have to write down tangent line approximation is, and always draw the picture to see that tangent line approximation is under approximation as f of x is CC up and tangent line is below. So that's all. Recently, we have learned second derivative, which is positive, negative, concave up, concave down, and that's where we are using whether the tangent line approximation is going to be above or below. Okay, so we are not going to look at this example. I don't want you to do it, but in the module, I have posted a worksheet. This worksheet is posted in the module. Answer key is in the file. Answer key is in the file. Please, please, please take a look at this worksheet and work on this worksheet. Most of the questions are easy, straightforward. I would like to do one of this problem with you, which is, let me see, this is really good practice. Guys, make sure you practice with the derivatives. Look at that, product rule, chain rule, again, chain rule, chain rule. This worksheet is a really good practice for all the rules. So, okay, I want to do number 7. This is a really good AP style question and free response, which you have to explain, justify. So L be the differentiable function. They already gave you derivative dl dt. It is known that L of 9 is 6. Equation of tangent line at 9. So there are 3 parts. So let's write the equation first. Y minus 6 is equal to slope x minus 9. This is the slope equation. This is my slope equation. I'm trying my best to write down. This is the slope equation. So what's the slope going to be? Let's write m first. So my slope is dl dt when L of 9 is a 6. So many times students are confused which is L, which is T. So think of this. This is T, L of T. T is a 9. You can say here T is a 9, L is a 6. So here you are substituting 6. Let me write better way. So y minus slope is 1/3 12 minus 6, which is 6 over 3. Slope is 2. So my equation of tangent line is y minus 6, 2x minus 9. This is my equation of tangent line. Okay, so that's the first part. Use this equation to approximate t is equal to 7. So you are using t of 7. So I have to approximate at 7. So my approximation is y equal to 6 goes on the other side. 2 times 7 minus 9, because I'm approximating. This is not x, I'm sorry, this is t, and this is L. L minus 6 is equal to 2t minus 9. Let's write the correct, let's use the correct notation. So this is again L. L is equal to 6 plus 2 times 7 minus 9. Approximation 6 plus 2 times negative 2. And whatever that answer, you don't have to simplify, just leave there. This is your answer. Approximation at 7. So you can say approximation at t equal to 7 is L equal to 9. Not 9, what's that number? Comes out 4, I guess. Okay, so now second part is my approximation greater than or less than? This is usually worth 2 points. This is usually more points. So use the second derivative. D square L over dt square. Pay extra attention. This is important. Derivative, if you want, you can distribute. This is 12/3 is a 4. Derivative of 4 is a 0. Derivative of 1/3 L is 1/3 dl dt. We are differentiating with respect to t. So my second derivative is negative 1/3 times dl dt. If I have to use this derivative at 9, so d square L dt square at t is equal to 9. L is what? What was my slope? Slope was here, we already got it, dl dt is 2. So this number is going to be negative 1/3 times 2, which is less than 0. So graph of L is going to be CC down. So my L of 7 approximation is overestimation. Approximation, overestimation, no, concave down. And why? This is already, we already proved that the second derivative is less than 0, is concave down. L of 7 approximation is overestimation than actual value. So all these answers are posted in the classroom. I was trying to make this video shorter, but then also I was trying to cover as much as I can. Please, 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 number 7, number 8 are very important questions. You have to know how to use the second derivative and approximate overestimation. This number 1 of the question is calculator active. So you can type this in a calculator as a Y1. On a home screen, all you have to do is math 8. I gave you the paper before. Maybe it's posted also in the module. You press the math 8, find the derivative at 7. That will give you the slope. You don't try to do by hand because it will take too much time. So please, please, please make sure you go over this linearization, approximation, all this, and this is very important topic in calculus. We are going to do this again in a second semester. So make sure you complete this worksheet. And if any question, concern, don't hesitate to send me an email. Thank you.